Hello, my name is Samuel Lewis. This is my presentation about volcanoes in the Pacific Northwest. This presentation will first go over pertinent definitions, then touch on the history of volcanoes in the Pacific Northwest, then the characteristics of volcanoes in the Pacific Northwest, then take a look at some of the scientific research that is going on in the region, then examine the risks and hazards the volcanoes of the Pacific Northwest pose. This presentation will teach you the historical and geological backstory of the Cascade Arc, teach you about how they're being studied in the modern day, and educate you about the threats and risks they pose to humans. To start this presentation, we are going to go over some definitions of important terms. Volcano. A volcano is a hill or mountain, typically conical, which is a vent or vents through which lava, ash, or debris erupts or has erupted. The volcanoes of the Pacific Northwest are a mix between shield volcanoes and stratovolcanoes. The Pacific Northwest. Not a formal region, the Pacific Northwest is widely agreed to be the portion of the northwestern North American continent encompassed by the United States Washington, Oregon, and the northern part of the state of California, as well as the Canadian province of British Columbia. Cascade Arc. The Cascade Arc is the mountain range in which the volcanoes of the Pacific Northwest are located. Shield volcanoes have lava that is not very viscous, meaning that it runs more easily and forms gentle lava flows. Shield volcanoes have a slope of less than 10 degrees and usually form from runny basaltic lava flows. Because of the low viscosity of their lava allowing gas to escape, they do not erupt with the violence of stratovolcanoes. The volcanoes that form the islands of Hawaii are shield volcanoes. Stratovolcanoes, also known as composite volcanoes, are made of layers of ash and hardened lava. They have a much steeper slope and much more viscous lava. Because of this more viscous lava, they trap gas, which builds up pressure, which then causes stratovolcanoes to erupt much more violently, spraying lava and ash across a large radius, triggering rock slides and devastating nearby towns and cities. Mount Vesuvius, the volcano that buried Pompeii, is a stratovolcano, as is Mount St. Helens and many of the other Cascade volcanoes. None of the volcanoes in the Pacific Northwest have erupted this century. However, in the scheme of history and volcanology, the Cascade Arc is quite active. Since the beginning of the 18th century, 7 Cascade volcanoes have erupted. The most recent of these was also among the most destructive. The eruption of Mount St. Helens in 1980, which killed 57 people, caused over $1 billion in property damage, and reduced the height of the mountain by over 1,300 feet as the top of the mountain exploded due to a buildup of volcanic gases. The chart on the right shows the history of eruptions in the Cascade Range in the past 4,000 years, which is a long time in terms of human history, but a relatively brief duration in terms of the age of volcanoes. The USGS estimates Mount St. Helens to be over 40,000 years old, with the foundations of the Cascade Range beginning over 100 million years ago, when dinosaurs still roamed the Earth. A study from Pivarunas et al. In the Journal of Volcanology and Geothermal Research reveals that though many of the volcanoes in the region are quite old, Ash Creek Butte and Crater Mountain, 2 shield volcanoes, may have come into being in less than a century, showing that though many of the volcanoes in the Cascade Arc were old when humanity was young, the region is still growing and in flux. Though the volcanoes in the Cascade Range are a mix between stratovolcanoes and shield volcanoes, the destructive power of Mount St. Helens, the most recent major eruption in the Cascade Range, has made the stratovolcano the definitive image in the public consciousness of volcanoes in the Pacific Northwest. The diagram on the right from the National Park Service shows how the convergent plate boundary between the North American and Pacific plates causes volcanic activity. The denser plate is subducted under the less dense plate, which causes the denser plate to melt in the high temperatures deep underground and turn into magma, which then rises to the surface. While people are enjoying the volcanoes of the Cascade Arc, scientists are studying them. Scientists have been doing a lot of work to study the volcanoes of the Pacific Northwest. 3 different areas of study that are being pursued in the region are hydrothermal alteration, mantle composition, and analyzing the magma reservoir system below the volcanoes. In an article published in the Journal of Volcanology and Geothermal Research, scientists found that the hydrothermal alteration has never ceased in the 500,000 years the modern Mount Rainier has stood, but has merely fluctuated in scale with the level of magmatic activity. This information is important because it helps us understand how the different systems that make up the mountain are intertwined. An article from Martin, Benderman, and Grove in 2011 studied the elemental composition of the magnesium of magma in the Mount Shasta and Medicine Lake volcanoes, prompted by finding high levels of magnesium in lava in the area. They used a process called laser fluorination to study the content of the lava. They found that high levels of magnesium were due to the large amounts of it being in olivine phenocysts. This study was important because it helped scientists to learn about how the magma beneath these volcanoes forms, to understand it as a catalyst for the ultimate eruption. A study from Dufik, Cashman, Hooft, and Bedrosian studied the magma reservoir beneath the Cascade Arc and found the placement of composite stratovolcanoes on the surface is correlated to the structure of the crust and the magma reservoir beneath them. This is important because it provides information about the underlying factors that went into the formation of the Cascade volcanoes. Though they may seem somewhat synonymous, in terms of volcanoes, threats and hazards have linked but different connotations. Volcanic hazards are the dangerous, natural phenomenon posed by volcanoes, like eruptions, landslides, and lava flows. The volcanic threat is the combination of exposure, which is people, property, and infrastructure being at risk from volcano, with volcanic hazard, creating a situation in which volcanic activity is both likely to threaten humans and their constructions. Now that we have a grasp of volcanic threat and hazards, we can look at how these concepts apply to the Pacific Northwest. The volcanic threat is high in the Pacific Northwest because both of its contributing factors are high. At present, more than 14 million people call Oregon, Washington, Northern California, and British Columbia home, which means that many people live near the volcanoes of the Cascade Arc. Many major population centers are near these volcanoes, which could put millions in danger when the volcanoes reawaken. Within the past year, there have been 7 earthquakes near Mount Adams, a volcano in Washington state. This is concerning because 7 is a higher number of seismic events near the volcano than normal and may be a sign that something has shifted. This does not necessarily mean the volcano is about to erupt, but it does mean that researchers should monitor the volcano more closely. The Cascade Mountains are majestic. They harbor tremendous volcanic power beneath them. Just because the volcanoes currently seem dormant, they could become active again, which could be devastating for the people of the Pacific Northwest. The eruption of Mount St. Helens was a major natural disaster, and Mount St. Helens is not even one of the 10 biggest volcanoes in the region. If one of the larger volcanoes, such as Mount Rainier, reawakened, the nearly 150,000 people who live in the area around it could be in serious danger. The volcanoes of the Pacific Northwest seem like beautiful mountains for now. They could once again rain ash and fire down on the landscape that so many people call home. It is essential that scientists continue to study and monitor this area to be ready for when and if the volcanoes reawaken. My bibliography. Thank you very much for listening. Have a nice day.